First, you read the question. A circular insulated copper wire loop is twisted to form two loops, as shown in the figure. At the points of crossing, the wires remain electrically insulated from each other. Entire loop lies in the plane of the paper. Magnetic field B points into the plane of the paper. At t equal to 0, the loop starts rotating about the common diameter as axis with constant angular velocity omega in the magnetic field. So if you have only one loop like this, suppose I am having one loop and there is a magnetic field going into the plane of the paper, and say this loop rotates in this direction. So actually if you see, if the area of the loop is A, if A is area of the loop, then at a certain time, now I'll go to another view. Suppose this is the x, y, and up goes z. Now if you view it from this side, say that is x and that is z on the top, and y becomes a cross. Then you will see the loop. So initially the loop is lying flat like this, and the angular velocity is along the y-axis. That means you will see it go clockwise. That means I am viewing it from here clockwise. So at a certain time, so this angle will be omega t, and the magnetic field goes along this direction, negative direction of z-axis, and this area of the loop, suppose this area of the loop is a, the vector area, this angle is also omega t. So the flux through the loop is b dot a, that is ba cos omega t. So the induced EMF in the loop is minus d phi dt, that is ba omega sin omega t. That is the induced EMF in the loop. That means there is an equivalent current in the loop. And if you see in the figure, ये फिगर में अगर देखो तो जब भी ये घूम रहा है, then this cross flux is decreasing. So this loop will, the induced current in the loop will be in such direction, it will try to maintain the same flux. So that means there is current in this direction, so induced current in this direction. So that means there is, if you replace it by a battery, so there is a battery like this, divided as a ba omega sine of omega t. Now in this problem, see what happens here. There are two loops, and if you look at the turn in the loop, it's wire passes over and it is like this. So if you see the upper loop of area A, you can put a battery here, say E1, and in the lower loop similarly you can put a battery E2. Now if you trace this current, see obviously the lower loop is having area 2A, so so E2 will dominate over E1, so E2 is more than E1. and ये जो current जाएगा देखो, from E2 induced current goes this way and via the upper loop this way and this way and this way. That means, so E1 and E2 will act in opposite cells. So that means the net EMF in the loop E is equal to E2 minus E1. देखो E अगर ऐसे रहता ना, सिंपल अगर ऐसे रहता, so A and 2A, then in this case E should have been E2 plus E1 because the sense would be same. ठीक है. By the way, so that's not the case here. Here the sense of the EMFs are opposite. So the net EMF is equal to E2 minus E1. It's not E2 plus E1. So here, so what's E1 equal to? See, E1 is equal to B A omega sine omega t, and E2 is equal to B into 2A omega, so it becomes 2BA omega sine omega t. So this net EMF E2, so E2 minus E1 is equal to, again it is BA omega sine omega t. So that means let us look at the option. First option, EMF induced in the loop is proportional to sum of area. It is rather proportional to subtraction, difference of the area. Let's look at the second option. Amplitude of the maximum net EMF is equal to amplitude of maximum EMF in the smaller loop. Yes, that's true actually. B is true. Because see, in the smaller loop, so E1, so numerically E is equal to E1. Their values are equal. Now let's look at option C. The net EMF induced due to both loops is proportional to cos omega t. No, it's not true actually. It is proportional to sin omega t rather. So C is not an option. Say A is discarded, C is discarded. Let's look at D. The rate of change of flux is maximum when the plane of the loops is perpendicular to the plane of the paper. Rate of change of flux d phi dt. So here rate of change of flux d phi dt is proportional to sin omega t. Yeah, so it's proportional to sin omega t. It is maximum when omega t is equal to pi by 2, or sin omega t is equal to 1, that is omega t equal to pi by 2. So omega t is equal to pi by 2 means the rate of change of flux is maximum when plane of the loops is perpendicular to the plane of the paper. Yes, the plane of the paper is actually the xy plane. So that means you see perpendicular to xy plane rather. So when it is perpendicular to xy plane, that's true. So यही तो है. When this omega t is equal to pi by 2, then the loop is perpendicular to the xy plane. So D is also a correct answer. So the correct options are, here in this problem, the correct options are B and D.